my unit outline. I'm sure that you have seen it from your Teams, your Canvas, but still I want to show you the unit outline. Please let me know if you cannot see. If there is no response from you, then I assume that it is okay and you can see it from the other side. So this is the unit outline for engineering chemistry semester 1. It will be 12 weeks as well, and in a broad sense or generally there will be this unit will have assignment, online quizzes, laboratory, that means laboratory works. It will be experimental work, and then tests. So the tests includes all the in-semester test and the final exam as well, all included. And the details are given next later into that unit outline. So please go through it. If you do not understand anything, this is the conditions that we will go by. So if you have any question or any inquiries, you can of course email me or ask me directly in the class as well. I'll talk to it about these learning outcomes later, and content as well. We'll come to the key program outcomes. You know that Swinburne engineering competencies that we follow, the basic science, maths, to prepare our students to be ready for the accreditation and to prepare a better engineer or to be accredited with the Engineering Australia and Malaysian Engineers Board. So there are some few options or conditions that we have to fulfill, and we have to go by these type of clauses, and the student will continue, would learn that from this unit how they can become accredited engineers, or they can be recognized by the professional body of engineers. So this is the things that we should learn, or we should, and that is why we will provide the test, and we will test you through this test and assignments and all those things to know that, yeah, you are ready. And unit improvement. Previously, the student said that assessment task was not clear last year, and not everyone. There was a comment that assessment task was not clear. So I have taken it seriously, and then this time I will try to make it clear from now and from the Canvas announcement before the assessment. Like if there is a test, you will know when, how, at what time, which way, through what medium you should attend the test, and what chapter will be included in the test, how many hours for that test, what type of chapter, whether it is a MCQ or it is a written test, everything it will be given in the Canvas announcement. And I usually do that, but I don't know, some student probably felt that it was not clear enough. So the instruction and description for the test always are given before the, at least 2 weeks before the assessment, always. It is your duty to visit the Canvas time to time. I can just put it on the Canvas, and I cannot force anyone to go visit Canvas time to time. Yeah. So yeah, if I have forgotten to do that, to update Canvas, please remind me. Email me to this email, and if I do not reply or do not modify or do not amend those things on Canvas, email me once again. There is no problem. Don't be scared to email me. Okay, it's sometimes that I forget. I'm busy with other things that sometimes I may forget, and then it will be delayed. So if you remind me, please, once again, that you emailed me previously, and then I have not done that. So what is the status? So I will know, then I will try to do it as, I will try to do take the steps to make it clearer. So assessment requirement will be put up through this Canvas announcement, and you will find it that week announcement. Usually what I do is every week there will be an announcement. What we'll do this week I didn't do because I already have announced it about the introduction class on the Canvas. So from next week on, there will be always an usually before the week there will be a announcement in the Canvas that what we are going to do in this week. And if there is a test coming or quiz coming or assessment coming, I will mention that in that announcement. So you have to go to that link and find what is the requirement for that announcement, for that test or that assessment, and how you will submit, what chapter you will take care of, and all those things, all the details you'll find that. So it is totally students' duty to know and check the Canvas time to time. We cannot force anyone to check the Canvas for yourself, yeah. And then lecture slides are clear with content. Some students say that lecture slides were not clear. Of course, there is a spelling mistake. There is a formatting mistake. So I have tried to remove it as much as possible. But if you see anything or typing mistake, yeah, if you see anything now, please let me know so that I can amend it as well. Better Canvas interface, so that every week you will find the information for each week in that week only. It will not, I will try to make sure that it does not overlap to other weeks, all right? So like first week things will be in first week, second week things will be in second week, in that way. And you can find by the week that which week we had that class or that lecture or that lab, you will find in that week as well. So, and you can of course email me from Canvas as well to my email. And I hope that the interface will be better this week, this time. And I am Bazlul, and I think many of you know already, and this is my room, E322. And I will be, I usually am in the class, in the campus, in the office, every day, except Saturday, Sunday, of course. Sometimes I'm there as well in Saturday, Sunday. And you can find me, and this is my telephone, my office telephone, and my email. This email is given there as well. So if anybody wants to do the consultation, they want to talk to me, even though I go to class, but you think that you need to talk to me in detail. So please email me first, or you can come to my office at 12 to 1 p.m. on Monday and Wednesday, 12 to 1 p.m. as well. So this is the lunch time. If you are coming, I'll be staying there. I'll be in my office that time if you want to come. By this time, this week, we will have a teaching staff, that is a tutor, Diane Kuno Shahira. She will be taking care of the labs. Taking care means she will be in the lab. I will go to the lab, of course. I will be there, but she will be there as well. But if I need to come out from the lab, or if I need to have something to do in the morning, I'll go to the lab. Or when is the lab time actually? When is the lab we have? Hold on. Lab is from Tuesday 1 p.m. to 4 p.m. 3 hours. So this lab, Nur Shahira will be there. Me will be there too, right? Where am I? Okay. I will be there and Noor Shahira will be there. So at 1 p.m. I'll go there. I'll talk to you guys and then maybe I'll come out after half an hour and then go again after half an hour. So I'll be on and off. If you have any question, you can ask her or you can wait for me to come back and you can ask the question as well. So that will be no problem. And yeah, so she will be taking care of the lab as well. And the lab report you have to submit before the next lab starts. So the provisional schedule for our teaching and learning activities will be followed by this plan, but it is not necessary that it is the very hard and fast rule. It can be changed because it's provisional and we do not know what will happen next week, right? So this is provisional that we think that we will go through this way, but mostly I'll try to follow this one. And if we have to skip something or we have to advance something, it will be announced through Canvas as well. Okay, so the learning structure lecture, we have those things. You don't need to talk much. You can see it. Okay, so today is 28th February and lecture was supposed to be atomic structure, ions and molecules, but I'll go through later. I'm going to the lecture later on. So yeah, and then this week there will be no lab. First week there will be no lab. There will be no tutorial. Okay, so only lecture first week. There will be only lectures first week and only second week. This is the week is beginning on March 7. So March 7, the second week, the laboratory, the introduction of induction to safety will start. Okay, safety induction for that lab. What should we do? What we do not do? All those things in the lab. We will start, and then we will do the experiment one. Experiment one is quite a simple thing. It is being developed or designed to bring a student back to chemistry again. It is some you kind of what do you call it? Titration. It's called a kind of titration. So hope that students will not be scared to do that. It is a very simple thing. And then from experiment 2 on, we will go much into more detailed or more, that takes much attention to that type of lab work will go. One thing that you should be take note that from week 3, we'll start online quizzes. Week 3 online quizzes, and this quiz will be by the end of that week, not at the beginning of the week 3 or week 5. It will be at the end, like it will be hanging there from Thursday or Friday until the Sunday. So you will have 2 or 3 days window to do these online quizzes. These online quizzes will appear in that respective week, like it will be on 3rd week. And student has to take that online quiz by these 2 or 3 days. All right. If anybody misses it, sorry, you cannot have the chance. If you do, then there will be deduction in the mark. Online quiz, please take note that it will be for a few days, 2 to 3 days, and you have to do it on time because you can access it through any of your gadgets. You can from your laptop, from your desktop, from your mobile phone, from your tabs, anywhere you can access these online quizzes and you can do it. So sorry, there is not much excuses that you cannot do it on time. So yeah, you have to do it on time. And week 3, before the lab starts, you have to submit your lab report. And this lab report is by group. So every group, student group, they will submit one lab report. And the grouping is by the students. So the student will choose their group members. And I think it will be better or it will be easier for you if you come to the lab, right? If you come to the lab, so you'll know who is who and with whom you want to form the group and do the work. So you can come on the first lab, that is week 2nd, and it will be Tuesday. 1 p.m. you can come to the lab, and then you can form the group. And yes, so that you know who is your group member or partner, and then you can do the work and submit the report by the next lab, before the next lab starts. And the submission is through the Canvas. All right, submission of lab report through the Canvas. No hard copy submission. Okay. Week 5, it will start on March 28. We will conduct the test 1. That will be 10%. That will be 10% of the total marks. So test 1 will be conducted week 5. Of course, I will be reminding you from week 3, but anyway, it's better to know from now. Okay, and then like this, it will go on. And there will be, where is that? Submission, assignment. There will be assignment submission by week 8. The assignment will be released by week 3 or week 4, or I mean end of week 3 or early week 4. The assignment will be out, or will be distributed among you guys, and you have to do the grouping for that assignment as well. But bear in mind, please, that you cannot have the same group as for the lab. Your lab group and your assignment group should be different. All right. So this is the assignment will be submitted on week 8. All right. By week 8, the assignment will be submission to be submitted. And this is it. The quiz is every alternative weeks. Okay. So week 3, there will be a quiz. Week 4, no quiz. Week 5, there will be another quiz. Week 6, no quiz. Week 7, there will be another quiz, like that. So every alternative week, there will be a quiz. And final test 1 and 2, as again, Swinburne, our university policy that there will be no physical class, and the exam will be conducted online for those students, those who are not coming back. So there will be the final test will be divided into 2 parts, final test 1 and final test 2. So final test 1, it will be through Canvas. You have to submit through Canvas. The link will be created, and the scope for final test 1 and 2 will be different. And what are the scope, or how many chapters will be included in final test 1, final test 2? It will be, of course, given you later on. So maybe around week 7 or week 8, I will announce it, what will final test 1 will have or will contain, and then final test 2. This is both are final test, yeah, but this one will be conducted during the semester, but final test 2 will be conducted at the end of our normal examination period, final assessment week. Do not miss the final exams. If you do, then there will be another special exam for you will be arranged, so that you have to go through all those things. All right. So the test 1 that will be in week 5 will contain 10% of the total marks. Assignment that you have to submit by week 8, and that will be distributed around week 3 or 4. At week 4, actually, assignment you will have 4 weeks to do. So it will be weighted, or it will have the weighting of 10% as well. Online quiz, 5 quizzes you will have. Then 5 quizzes, each is 3%. Weighting is 3%. So altogether is 15. Laboratory is 20% for all 6 or 7 experiments. If we have the time and chances to do, we will go for the 7th, but if we don't, we will have a 6th experiment. And then final test 2 is 20%, and final test final test 1 is 20%, and final test 2 will have 25% in the test. What you should do to pass this unit? But bear in mind that is just to pass this unit, okay? Barely for passing that unit. Those students who are committed to do that, you want to do better. You want to show that you know chemistry, or you are attentive to the class. It is not for you. You know that how to cut a good figure in the exam. But if, God forbid, something that we should know that what is the minimum passing criteria, all right? You should achieve at least 50% or more in this unit altogether, overall. Okay, so just make sure that in any assignment and test and quizzes, you are making 50% and above. Okay, so that you are safe for everything. You are safe if you are making 50% and above. Achieve at least 40% in the final assessment. The final assessment, that is 20 and 25%, right? Just now we have seen 20 and 25%. So 45% is the final exam, which has been divided into. You should get at least for 40% for both of these to pass this. If you do not get 40%, of course, you will receive 45 maximum, and then the total marks for this unit, and then it will not be successful for you. God forbid. Okay, so the examination will be conducted as per the university's regulation, and then how the university asks us to do. And all students should be available during the examination period. If is there any special exam, you should be, expect you to be there, at least even for the special exam. All right, submission. You have to submit it through Canvas. All right, but if you submit, we do not believe the system can crash anytime. So keep a backup. Keep a backup. I do not know how you will keep a backup. Usually it is good to have a hard copy if you want to keep it, or if you want to keep it in the cloud or anywhere that you trust, you can do so. But keep a backup if anyhow it is lost, and you can have you are safe still. Otherwise, you have to do all over again. And when you're submitting the assignment, right? When you're studying assignment and and lab report, you have to submit with a assessment cover letter. Okay, the assessment cover letter, you can find it from the first week of module. What is the first week or before that? The module. I have given the assessment declaration form. You must submit it with the assessment declaration form for every lab report and assignment as well. Extension and letter submission. Please listen carefully. If you really need to extend your submission and you have a accepted excuse or reason, better say, you have an accepted reason, that is sick leave, MC, or emergency that you can prove, then there can be an extension. There can be an extension, 2 to 3 days, if you have a very valid reason. If you don't, then every time you will have 10% of marks deduction. Every day, for every 1 day delay, 24 hours delay, you will have 10% of your marks deduction from that assignment. Like 3% lab report, you are delayed by 1 day, you will have 10% of that 3 marks deducted already before I have even start to evaluate, automatically deducted. And then 2 days, 20% deducted, 3 days, 30% deducted. So until 5 days, that is 50% deducted. And then after 5 days, you will not get any chance to submit. And if you even do, you will get zero marks. I'm sure that you don't need to do that. Our students are, for this cohort is good, but sometimes it is better to be fair. We know the rules so that we can play by the rules. For required textbook, there is no There is this textbook, but the information will be collected or will be provided from different books and different journals as well. So for our required reading, Raymond Chan, the Chemistry 10th edition, this is good for our inorganic chemistry, and Robert Olliott and David Ron, 2019, this organic for the organic chemistry that we will come later on around week 8 or 9, we will start organic chemistry. So this book will be good, and both of these books you can find from the our Swinburne library if you log in through this, so that you will have the books, you will have the access to the book. If you cannot, please let me know. Okay, so is there any question so far? Jonathan says that already the campus. Yeah, that's great. I'm missing campus as well. So I can expect that it will be a very interesting interaction between you guys. Yeah, 1, 2, 3, 4, 5, 6, 7. All right, 7 of us can go to the campus, including me, 8, of course. So 8 of us will be in the campus, and it will be good interaction class then. Yes. All right. So is there any question? No. It's good. Yeah. Clear. So now let me show a little more integral thing that what it needs to get a good grade in your any unit, not only this unit, but any unit. Let me share the slide with you. Okay, for my unit, engineering chemistry, what it needs, and before that, let's see what is the aim for my unit. Introduction to the basic concept of chemistry, and I'm sure that you already have it from our foundation. And then you will see a lot of the foundation stuff or the information is coming up, and probably you'll think that, oh, why we are doing this again? Because I need to refresh our memories on our foundation, or our chemistry that we have learned from the foundation, to go into detail that we'll count later in the weeks. Okay, so bear with me if you even see that it is very much similar to what you have learned in the foundation, and it will be different. It will be different when we go into week, 5 or 6 and more, up. So we will need the foundation, the basic chemistry knowledge, and what we can do with it, how can we use it, not for our professional life. We are not thinking that we are in the second year and we are not thinking about the professional life as yet, but how it will be helpful for us in learning the other units that we will learn in next in our week 3, year 3 or year 4, or even for our final year project, how it will be helpful. So this is one interesting thing that will be structure of elements and compounds and their interaction with each other. We know the structure of atoms to some extent, but we will know in detail of it, of course, and the compounds or elements, how the elements are structured or formed in a compound, and based on their structure or their physical appearance, how do their physical and chemical property differs. All right, so we will know that when that one. This is our aim to know as well, and the various reactions of elements and compounds that we will, of course, we will try to investigate. The quantitative aspect of chemical reaction, Okay, we have seen the chemical reaction that it's very hot, it gets cold, there is a smoke, but how can we quantify the outcome of from that chemical reaction? That means we can measure and note it down on the notebook. So that is our aim. That is it good, bad, we understand, but how can we actually note it down? So that is the thing. And basic practical skills, of course, and safety, the safety precautions and chemical safety in the lab. We will do that as well in the first day. Content, structure of atoms and chemical bonding. We will learn in the first 2 weeks because the first lecture will take a long time to finish all those things. Many of you, I mean, many of those content you already know, but I'll refresh it once again. The mole concept and chemical calculations. You know that if you don't want to do the chemical calculation, the mole concept is quite important, and it will be interesting that I think that you already know what is mole, what is molarity, and how to calculate that, what is the Avogadro's number, all those things. Chemical equations and stoichiometry. So these are some terms. There will be some terms that will come up. Don't be scared. Don't be worried about this. This is a simple thing. If we learn, we'll see. And acid base, and then halide, hydrocarbon, halogen, and halides and alcohols. So all these are particularly from organic chemistry. So we'll learn this after week maybe 7 or 8. We'll start something like that. Depends on our progress, how fast we can complete this thing. So to criteria to pass this unit, before passing, we talk about passing, we need to know what is the thing that we will do. Your attendance to lecture and practical session are compulsory, even for your, online or physical presence, but you should be present. Not in all lecture, but for all practical session, you should be present. You should attend. Even if you do not attend the practical session and then you submit the lab report, or your friends or your group members submit the lab report, you will not get marks for that. Your friends will get, those who are present or who attended that session, but you will not, because practical is a hands-on training. If even you submit your lab report, that means that you do not have the hands-on training. You just have the theoretical information. So be careful and be clear on that, that if you do not participate in the lab work, even through online or physically, those who can come physically to the lab, good. If you cannot come, then online, you will not have the marks. Okay, usually we do that. That is our normal practice. But if you are unable to attend due to some very valid reason, so let me know, so that we will consider it and we will review your claim. Okay. So that assessment task that I just mentioned, that more than 50% in all in semester test and assessment and quizzes and everything, you should get at least more than 50% or more, 50% or more. In the final exam 1 or final exam 2, you should get more, 40% or more. Okay, so that to pass this. And if you are submitting late, then the marks will be deducted. So student characteristic now. What are the difference between high distinction and pass, or distinction and credit, or in between them? All right, high distinction, those, and bear in mind that our students usually in this unit, they really do good. Okay, High distinction. The students that will take responsibility on their for their own learning. Okay, so do not wait for the things to start or that everybody asks you to do this and that and those. You become proactive. You can. The university is for you to become proactive. Okay, you know that this is who is what and who is doing what and where you can find the information. You can go to the lecturer, you can go to the lab assistant, you can go to other student, you can go to the library to get the information. So be proactive, take the steps to learn more, to get the information. You see that we have information, I mean, we have the same we almost know everything. All of us know the chemistry we have good basic. We know that this is this is those. But some of us will be proactive and have more information to get better, to do better in their exam. So if you are proactive, you can get those information and get the good result and do good in the exam. And of course, your grade will be higher in that way. Okay, so so this is high distinction, HT. There is not much difference between distinction and high distinction. Distinction, they're good student, they do good, they learn, they study, good thing. But high distinction, they are a bit more proactive. They go and seek the information. Okay, they are more active than the distinction students. That's it. There is not much difference between high distinction and distinction, although it's different. It's quite heavy on your result sheet, but for in a real world there is not much difference. Only the difference is the high distinction students, they are a little bit less proactive than the high distinction. That's it. Okay. For credit student and the student, they usually know or they want to show that they know or they only know how to do it, the problem solving, and those problems solving only by the books or only on the lecture slide or that has been given to them, but they do not want to go through to the to do by themselves. They do not do the self-learning. All right, so that is the students. There's a credit. Sometimes, most of the time, I'll say that the credit students are good students, but they are, how do I say that, not serious about doing the things to go a little bit further, take a little bit more, one more step to go to find the books, what is written in the book, and try to solve the problem similar problem, not just the problem that has been given. Okay, ask question to your friends. Start to make a group discussion. You initiate it. Don't wait for other student to initiate it. You initiate it. All right. You go and say that, hey guys, can I have a meeting today? And then we learn this thing. What do you think about it? Make some quizzes, make some jokes about what you learned. So by this way, the more you interact with others, the more you will learn. All right. And the student who just want to pass, it is very easy to just want to pass. All right. But at the end, you will think that why you didn't do a bit more to get a good result. It is easy to do passing. You can just attend the class and then see what is going on, what we are talking, and you just take care of those, and that's good enough to pass. But yeah, everyone should try to strive at least to do better. Not only for this chemistry, for every other units as well. So practical study suggestion, and this is the learning pyramid actually, that from the lecturing, we know around, very little from the lecturing. from reading after the lecture that we will teach you will show you the connection from where you can get what, and or make some bridges of your thinking, or if you have any inquiries, we can we can address that, or if you want to have some bridges, information gaps, we can provide those one. But afterwards, if you go and read the books, you will learn more. After that, the demonstration, audio, visual, discussion in the group, practice by doing, and then teaching others. So in the group discussion, you can take turn, 4 of you in the group, you can take turn of teaching each other that we know this thing, this will be happening in that way, or this is this actually. So, by teaching that way, you will learn more. And this is learning pyramid. This is not made by myself. This is a well-established learning pyramid from the education. So you can trust this learning pyramid as well, right? Okay. So yeah, deep learner and surface learner. There is another thing actually. This is not related to HD or D. Any surface learner can also be a very D student, all right? But deep learner, they have intrinsic curiosity about the subject. They delve into the matters, into the content. They go and do by the things, and they are really interested to learn more about it. And surface learner, they just want to pass. Okay, just go. I just want to do I want to finish all the problem in the exam that is given, or assignment, yeah, but I don't want to learn, or they do not take the pain to learn deep, right? So deep learner, this is what do you call it? Demanding characteristic. Actually, we should be a deep learner to help us become successful in our 3rd year and 4th year. Deep learning is very important actually, that's why. All right, so this is what it is needs to get a good grade. And if you have any question, you can ask. If no, then if you have any questions, sorry, where is that? Okay, no questions so far. If no, then I'll take maybe 5 minutes break, and then I'll start the first lecture. I'm not going through everything, but maybe for a few minutes I'll go through the first lecture. But by this time, if you have any question, you can ask. Yeah, I'm here, and I'll take a 5 minutes break first. Jonathan, you are in the campus now. So how is the situation in campus? A lot of students there already? Really? Oh, so again, it's hard to find parking, yeah? The only thing I would miss back in campus is parking. Oh, parking is okay still? All right. Oh, okay, that's why, yeah. For these last 2 years, the parking was so easy for me. But I want that situation again when a lot of students are there. Even though parking is hard, but still okay, as long as students are there. Okay, all right, let me go directly to the class today. I mean, the lectures things today, because I will not go into the core thing, but before that, core means the atoms, structure of atoms. I think I will discuss a bit about the atoms next Thursday, the coming Thursday, and then the whole thing will complete by next Monday, hopefully. By the way, next Monday I will be still on quarantine things, so that I will teach online, and next next week Thursday, hopefully, I will be in physically class. Okay, but the lab next Wednesday, you can go to, you should go to the lab, because Dayanko nor Shahira, she will be there, and I will be connected through MS Teams for the only for week 2, and for week 3 and week 2 Thursday on, that means week 3, week 4, all the weeks I will be physically in the lab if everything goes fine. Okay, so now this is okay. Matters, atoms, molecules, and the calculation. Since it is calculation, the term is calculation, we have to know that everything in numerical values. And when there's numerical values, and it will be very handy for you guys when you submit your lab report, that the part that I'm going to discuss now, it will be very much handy, and we will expect you, the students, to do it as per the engineering practice. All right, so please pay your attention, and once it is done, go through the this lecture slide, which is you can find from the canvas, to understand the concept of calculations or numerical figures, or significant figures, in fact, for preparing your lab report. So for this scientific figure, significant figures, uncertainty, all those things we will be learning. Afterwards, we'll learn the structure of atoms and atomic mass, moles, analytical and empirical formula, all those things. But before that, the SPD notation for the atoms and electronic configuration will come later on. But before that, the scientific figure and significant figures, these things we will learn first. Before we goes directly into the scientific and significant figures, why do we need to study chemistry? What does it tell us, or how we be benefited from chemistry, or what aspect that we will get benefited? For this, you can discuss anything. you can talk any aspect of our science and development. Any. You can say food and health. You can say material in technology. You can say energy and environment. You can say anything. Food security. Chemistry is involved in a way. It is probably not directly related, directly chemistry, but it's the branch of chemistry. It should be. All right, anything that you can talk. So that is why chemical knowledge is very important for us to understand at least the basics, so that we will not be left out and then wondering what where the world is going, right? So that is why, and it is so obvious that we don't need to talk in details. We understand food and health and medicine, that it is very much related to chemistry. Now energy and environment. Many of you, I remember that you have taken foundation, and then there was the project, right? Energy project, renewable energy. So you have seen that much of it related to chemistry as well. If even, I mean, if you go into the basic of it, material technology, the production or developing new materials. So chemistry knowledge or chemical information you will be needed. Food and agriculture, of course, everything. It is related to chemistry very much. So that is why the chemistry is a very important thing for our 21st century. And how can we measure that how much of a matter or a material will be needed? When we talk about measurement, the qualitative and quantitative terms come along, all right? Because two ways we can measure. Like we can say that this is a very good book, right? This book is a very good book. Or another way, another person, they can say that this book is 10 inch long and 6 inch wide. Or it is the book weighs 1 pound, half of a kilo, something like that. So there are two ways to describe one specific thing, that you can quantify that by measuring it, by proving to other that this is the dimension, or it has this much weight, this much width, length, or this height. And you can say it is good, bad, or is pleasant, that we cannot measure. We just perceive. And this that is qualitative, that we cannot measure. Okay, we can hear, see, smell, touch. We can realize this thing. Those are the qualitative thing. But those which are, those which are do the measurement, that I can show you, I can prove you that I'm claiming this is big, this is small, this is high, this is hot, this is cold. I can prove you in that way. That is the by measurement. And if I prove, you have to accept it, because those method of proving it by measuring it is universally accepted, like the ruler, right? Or the weighing balance, or the thermometer, or everything is, you cannot say that I don't accept this thermometer. You cannot say that, because this thermometer, it has been accepted or has been regulated by the authority. So we have to, we always abide by those. So this is the quantitative observation. Sorry. So qualitative observation, the gas is being going out from the bottle, from the test tube, and we can see that gas, but we cannot make others to see it. Maybe my eyesight is better, or your eyesight is better, you can see, I cannot see. So you can tell me, I will see. But if you say that, okay, 5 liters of carbon dioxide, evaluated from this chamber or from this bottle, and I measure it that it is really 5 liter, so I'll no way I will have the chance to say, no, I don't agree. I cannot say that. So that is the, so this is qualitative and quantitative. These are the two things that qualitative that we cannot measure, but we can perceive through our senses. That is the qualitative, but quantitative is by through the measurement, and we cannot say, and it is evident. There is evidence for that quantitative measurement. So you have already understood that we will be only talking about the quantitative. Qualitative, we will not talk about it, because qualitative, it is much related to person. It varies from person to person. That is good to you, maybe not good to me, or what is good to me, maybe not good to you. So it is very much it is very much it depends on the person or the subject. So we will not talk about it, but we will talk about the quantitative, what we can measure, what we can prove, and that is very important for our engineering perspective. But don't forget or don't ignore the qualitative observation as well. When you're an engineer, you have to consider the qualitative as well. All right. So later you will learn more, but yeah, just the thing that we cannot ignore totally the qualitative and only focus on the quantitative. Quantitative is very important for measurement, but qualitative is important for aesthetic purposes. We have to make the things or a product presentable to others, so we have to know how it will be good looking, good sensing, good smelling, or all those things. So yeah, qualitative is important to some extent, but later we will need it. So for quantitative, every measurement, we have number and unit. Only number does not tell anything. 10, 20, 0.5, 100, it does not tell anything, or we will not know anything by that unless there is an unit. All right. So unit will be feet or millimeter, centimeter, meter, cubic meter, all those things will be the unit. And when there is an unit, when there's a number, in fact, well, there is a uncertainty. All right. So when I'm saying that it is 0.5 or 10, 20, there is already an uncertainty, because there is a tolerance for the instrument I'm using to measure that, or 100 gram. All right. 1 feet or 10 degrees centigrade. All right. 10 milliliter. Every time I'm telling you one thing, I am giving you uncertainty in that number. All right. So this pen is 10 meter. I don't know whether you can see me. This is another problem for using the background. I hope that you can see me. This is a pen. Hope that it will be good. So this is a pen, and I'm claiming that this pen is 6 inch long. All right, this is 6 inch long. Let's say 6 inch long. How did I measure it? Hold on. Okay, how did I measure it? I used a ruler. Excuse my drawing, but I used a ruler for this type of measuring the pen, right? This ruler has been standardized against the standard ruler, but during that process, probably there was a mistake or some uncertainty here. So the ruler can only measure until when there is this type of graduated the sign. These are the graduated sign, right? Let's say this is 1 millimeter. Between this gap, this and this gap, this is 1 millimeter. Let's say it's 1 millimeter. 1 millimeter. Oh my God. Okay, this 1 millimeter, this gap. So if my pen is here, this big, this long, and E, the head or the tail, you can see it is in between two lines. In between two lines. Can you say that, okay, this is 0.5 millimeter, since the one graduation or one between these two lines, the space, the distance is 1 millimeter. So it is in between that line. It is not aligned to this point or to this point. It is in between. So we cannot say that it is 0.5. We do not know. That's why you cannot say, right? So that is the uncertainty. We have to always consider that there is an uncertainty in measuring the quantitative observation. So how much is the uncertainty? When there is 20 milliliter, only 20 milliliter, that means what the scale I used, it can measure every 1 degree graduation, or sorry, 1 milliliter increase. Oh, sorry, the milliliter means it should be a volumetric flask. So when I use that volumetric flask, the flask can measure, or the pipette or burette can measure every 1 degree graduation. In between, 1 milliliter graduation. In between that 1 milliliter, it cannot detect anything. So if I have 20, I do not know, it is 20.9. It can be 20.9, or it can be 20.1 as well. And I will not know. If you look at the scale, if you have a ruler with you, if there is the centimeter, there is no marks on the centimeter, like 1 inch, 1.5 inch, 2 inch. And between that, there is nothing, no other graduation on any other mark. So we will not know whether it is 20.1 or 20.9, right? So there is the uncertainty is quite high, about 1 milliliter. We will not know whether it's 20.9 or 20.1. So almost 1 milliliter, the graduation, the uncertainty. But if we measure and express in this way 20.0, that means we can detect that, okay, it is 20 milliliter, but it can be 1/10th milliliter this way or that way. So our tolerance, or our uncertainty, is reducing to 0.1 milliliter. Only this part. We will not know whether it's 20.01, okay, 01 to 20.09. 20.09. We will not know in between this. But if it becomes to 20.1, if it becomes 20 more than this, if it becomes more than this, so it will become 20.1, and then we will know that, okay, it is 20.1. Okay, because it is graduated on the scale, on the ruler. So our uncertainty is only 0.1, 0. Plus minus 1, it will be our uncertainty. And this one, so how the more sophisticated is your measurement tool or measurement balance or scale, the smaller the uncertainty. So now, can anybody tell me which one of these A, B, 1, 2, 3, 4 will give us a more precise result? Which one will give us a more precise result? Can anybody guess? Audrey, number 4. Jonathan is typing. I'll be waiting for Jonathan. Why don't you just unmute yourself and talk? Ainin, quite many of us are talking. 4, Ainin said 4. Okay, 4. Math. All right. 4. Okay. So it's good that we know actually it is the 4 is much more precise and much more sophisticated, right? Because the uncertainty is quite low. 0. This is 1. Number 1 is 1. Number 2 is 0.1. Number 3 is 0.0001. 4 is even lower. So number 4 will give us a much precise, more accurate result. And then significant figures. Every measurement, we have, let's say that 90.6.55. And here we have 116.31, trial 136.11. All right, so this is quite big difference in the measurement, but this is just for an example, for example purpose. So yeah, now we see that here we have gram, the unit. Here we have degree centigrade. Here we have milliliter. So three different type of measurement. And we, for this thing, we needed 3 different type of instruments to measure. What it can measure gram does not measure milliliter. What it measures temperature does not measure gram or weight. So different type of tools we used for measuring this thing. And for this case, we see that a container adding 20 milliliter of water, right? Oh, we should calibrate it. The class B type of a graduated pipette at 25 degrees centigrade, and it is 20 milliliter. So what we'll do is for this, in the lab, for all the instruments, we will try to calibrate it first. All right, we'll calibrate it first, even though it is written 20 milliliter or 20 gram or 20 degrees centigrade or 20 meter length. We have to calibrate it first because our lab condition may be different than that is written for that instrument. Maybe the instrument is at for 50 degrees centigrade or 20 degrees centigrade, but we are using it 30 degrees centigrade or 28 degrees centigrade. So because if we want to be precise, and our lab work is quite, it needs very some precision. Okay, and every analytical work need precision, and that is why we have to do the calibration first. If we do not do the calibration, and on that assumption that it is 20 milliliter, 20 gram, it will not give us the exact, very precise result because our lab condition, the temperature, pressure, and all those things, maybe our water density is different. So because of that, we need the precision. And when we go for the analytical work in the industries, maybe, or let's say for we are going to produce medicine, right? And for medicine, for human consumption to cure us, if there is a little bit difference, even for 0.001 difference, it can be deadly. So because to avoid those things, we have to use the, okay, we will see later on how do we do the calibration, but most of the time our calibration is done by our lab staff, thanks to them, because it takes time so that we can focus on our main things. But we have to know how to do calibration. Okay, so let's say that the graduate pipette, we want to calibrate it at 20 degrees centigrade, 25 degrees centigrade, and we know that is 20 milliliter pipette. So what we do is first we take the water, 20 milliliter water, and then we measure how much is the gram altogether of the container. Altogether, the container, we see that the first trial, it is giving us 96.55 gram of water altogether, not only water, water plus the container. Second trial, it is giving us quite big, 116 plus 31.31, and then 136.11. Trial 3 is giving us the number, this is the mass of water plus the container. Okay. And the mass of container only, before I put water into it, it was for the trial 1, 76.62, and then it was 96.55, 116.31. So for all three, we see that the water mass of water was 19.93, 19.76, 19.80. So you see that the mass of water for all three containers are almost similar. Almost similar, but even though almost similar, but still different, quite much different. 809376 is quite different. All right, so for this case, we have seen that it is three significant figures, because this, all of those figures, 25.0, even 0.0 we are considering. Every time we are telling that it is 0.0, 25.0. If it is written and one student say, okay, it is 25 degrees centigrade, it will be wrong. We have to tell the 25.0 because the tolerance or uncertainty you have reduced to 0.1. All right, you have reduced to 0.1 the uncertainty. And for this case, it is only one significant figure. All right, it is two significant figures. Sorry, yeah. So 20 is two significant figures, is three significant figures. For this case, it is five significant figures, 116.31. All of them we are counting, and this is four significant figures. So this is four significant figures. This is four. So there are different type of significant figures we are using, 3, 4, and 5 significant figures. Now, how do we find the tolerance or uncertainty for this type of measuring devices? For these digital measuring devices, it will give us the tolerance. It will be giving us in decimal places, like the temperature. Let's say we are using a digital thermometer. So it is already giving us 25.1 or 25.0, like that. So we can write 25.0 plus minus 0.1. Plus minus 0.01, right? So this is, of course, it will be based on the digital thermometer specification. The digital thermometer that will tell us, or the digital balance, it will tell us what is the uncertainty for this temperature measurement tools instrument. But if it is not digital, if it is an analog one, what we will do is the small graduation between them. Let's say that this is a thermometer, right? This is a thermometer, and there the graduation is, this is 0 degree, then this is 1, 2, 3, 4, and then 5, right? So this is 1 degree and this way. So this every graduation is 0.02, right? So the graduation between them is the division. This is the division that we are looking for. So what is the difference between them? There's 0 and 0.1. Sorry, 0.2. So it is 0 and this is 0.2, we understand. So what we'll do is 0.2 divided by 2. So for our analog, this is an analog thermometer. Our tolerance will be plus minus 0.1. Plus minus 0.1 for our analog one, because it is not given there, it is not written there, so we have to find it out. But sometimes on the analog thermometer as well, it will be written that this thermometer works at 20 degrees plus minus 0.1, something like that. So yeah, we can use that one as well. But if it is not written, then this is our formula to find out what will be the tolerance for that instrument. Number and scientific notations. Scientific notations are used, and sometimes we will be using some, not sometimes, most of the time in our lab report and all those things, we will be using the scientific notations. And these are quite important because we have to deal with a very big numbers, Avogadro's number, right? You cannot possibly write 6.23 times 10 power 23rd, right? So you cannot write that 623000000 23 zeros, you cannot put in that way. So scientific notations are quite important. And even if this is this type of small number, considerably small number, we cannot write all the, it is time consuming, you will lose your time in the exam, and also it is quite boring thing to write all those zeros in front or at the back. So that is why scientific notations are important, and we have to express this 10 power number, so it is easier for us. And this scientific notation, when there is a 10 powered figures, we need to add or subtract or multiply or divide by one another. Nowadays we do it by using calculator, but the concept behind it is either we have to change this 10 power third, 10 power fourth to 10 power third, or 10 power third to 10 power fourth, and then it will be unique, and the rest of the things is easier to add up for addition. For multiplication, this powered will be added all the time. The powered will be added, and the rest of the thing will be multiplied. For division, this powered will be subtracted, and the rest of the thing will be divided. So this is how the addition and subtraction goes. Significant figures, as again we have seen it. So this is a 5 significant figure, 1, 2, 3, 4, 5, and this is only the uncertainty. So this may change, right? This may change. It can go up or down, and we cannot say that, okay, it is exactly 4.0301. It can change to 0302, 0305 until it goes to 0.039. Up beyond that, then it will become 31, right? Until it goes to 9, it is still 0.3, so we will not know if it changes. So this is why it has a significant figure. Uncertainty is 0.0001, and for this case we will not know if it is 15.1 or 15.2 or 15.3. So until it goes beyond 15.5, so and then it will become 16, and that is why it has a uncertainty is point plus minus 1, right? So if it is 15.9, still it is 15, it will be showing, but it is 15.0 and 15.9 is a very big difference, but we will not know if that instrument does not have that sensitivity. So that is why the uncertainty is plus minus 1. For this case, it is 1 place after the decimal, so it is significant figure is plus minus 1 here. How do we calculate or count the significant figures? Non-zeros always count. Where is my cursor? Okay, so non-zeros always count. Everything should be counted. for significant figures. The zeros between non-zeros, doesn't matter whether it is before or after the decimal places, should always be counted. And then zeros, trailing zeros, the zeros at the end of non-significant figures, okay, of significant figures after the decimal places should be always counted after the decimal places. All right, so it should be always counted. So this is significant figures. But if the zeros are before the non-zeros, it is not counted. Doesn't matter whether it is before or after the decimal places. So the front zeros are never counted to count the significant figures. The trailing zeros are not counted. It doesn't matter whether it becomes 1 million or 1 billion. It is not counted. It is only the non-zero one is counted for significant figures. And the infinity numbers, that is pi number, or if you divide 10 by 3, you will get 3.333333. I mean, it will continue till the end of the word. So those trailing figures are not counted for significant figures. All right. So yeah, these are the rules for the thing. Now this is the determination you have to go through. This is the 4 significant figures, this is 3 significant figures, 3 significant figures, this is 2 significant figures. And okay, the scientific notation, these 10 powered figures are never counted for significance. Before that are always counted. This is 4 significant figures. So this 10 powered whatever doesn't count in a significant measurement or counting. For 7,000, this only 1 significant figures, because the trailing zeros are never counted for significant figures. All right, rounding off. Sometimes we need to round off the significant figures, the figures at the end of our last operation. So rounding, we already know that if it is after the decimal places, if it is more than 5, right, we will round off to the next, round up to the next number. So 4.327, so 2 will be rounded up to 3 if it is more than, the 7 is more than 5, that's why. And if it is less than 5, 4 is less than 5, so it remains the same, 16.2 to 3 significant figures. We are rounding up to 3 significant figures. All are up to 3 significant figures. If the digit before last retained digit is 5, then yes, we will round up to 18.4. But if that digit is even, 4 is even, all right, 4 is even. 4 is even though it is 5, but 4 is even, and that is why it will not be rounded up. It will remain as it is. Since 3 is odd number, so it will be rounded up. For even number, it will not be rounded up. It will stay as it is. It will be unchanged. So these are the ruling for significant figures. Addition and subtraction for calculation of significant figures, that for addition or subtraction, whatever at the last digit, the last figure at the end of our calculation, at the end of our operation, the last digit should always follow the minimum number, the significant figures. Like here, we have 1 decimal place, right? This is 1 decimal places. But for here, we have 4 decimal places. So this is 4 decimal places. Oh, okay. And this is 1 decimal places. So the last result or value should contain only 1 decimal. It will follow the minimum decimal places in all the, if there were more to add on, there are more figures like 2.385 or something like that. So it will be 3 decimal places. It doesn't matter how many we add up or subtract or multiply. So the the number of decimal places should, in the final result, should follow the minimum value. Here there is only 1, so the last value should be only 1. If there were, you were adding up 5 values and the minimum of those 5 values were 2 decimal places, so your final result will contain 2 decimal places. These things you should take care when you are preparing the lab report and also in the exam or test. So there will be marks allocated for this, even though it is not shown in the question paper, but the marks will be allocated on those things. It is hidden, of course. We expect a student to know, and if you do not follow, your marks will be deducted from there. The same thing goes for here when we are doing the multiplication and subtraction, division operation. So the final result will have the lowest significant figures. So here we have 3 significant figures and here we have 6 or 5 significant figures. The final result will have only 3 significant figures. You round up or round down or unchange, but it will have 3 significant figures. It follows the minimum number of significant figures for your multiplication and subtraction, division. For your addition and subtraction, it will follow the minimum number of decimal places. Okay. And this is the examples for you to try later on. You can try, and if you have any question, please let me know. It was supposed to be tried in the classroom. Okay, so accuracy and precision. What's the time now? All right, so I think I'll stop here today. I don't want to bother you at the first date, but yeah, I'll start next week. Next Thursday, accuracy and precision, and then afterwards I'll start the atoms and figures, atomic structure of that. All right, so all right, so do you have any questions so far today? Anyone? All clear, Chewen. Okay, good. All right. I know that it is you already are familiar with those things that we discussed, and you have actually tried something, but some of you maybe need some refreshing your memories. That's why we try to do that. And don't worry much. This is the first week, and that's why I took the opportunity to refresh our memories in the first week, because in the first week we actually do not go into the much detail of the hard things. Later on, from next week on, probably we'll learn more about chemistry, hopefully, if everything goes fine. So until then, until next Thursday, on Thursday we have class at, let me check, still first week, so I need to check back time to time. On Thursday, we have class at 2 p.m. Malaysia time. So I'll see you at 2 p.m. Malaysia time through these MS Team links. All right. And there'll be no lab, no tutorial this week. So I'll see you Thursday, 2 p.m. Take care and bye-bye then.